Hello everyone, this is Neeraj Kumar Gaur, Assistant Professor, PCA Department, IIMT College of Management. Today I am going to give an online lecture on permutation and combination. Let's start. Permutation and combination. The fundamental principle of counting. Number one is called multiplication rule and number two is called addition rule. So in fundamental principle of counting, these are the following two counting techniques that we will be studying. Number of different ways of arranging. In this, we count the object by arranging them. Number two, selecting different object. Here we select the object first, then count them. So the first one is called multiplication principle. We also call the rule of n. Let there be two events, A and B, in an operation, and if these two events can be performed in m different ways and n different ways respectively in succession, then an operation can be completed in m into n ways. So this is a pictorial diagram. Suppose event A, different number of ways is n, event B, different ways is n. So the total number of ways for two events is m cross n. So let's take an example. There are 3 ways to travel from Kota to Jaipur and 4 ways to travel from Jaipur to Delhi. In how many ways can a person travel from Kota to Delhi via Jaipur? In how many ways can a person take a round trip provided that the same road has not been taken while coming back to Kota? So solution for step 1. Let the 3 ways of traveling from Kota to Jaipur be given by x, y, z, and the 4 ways of traveling from Jaipur to Delhi be given by 1, 2, 3, 4 as shows in the figure. Step 2. Now a person can choose path x and then path 1 to reach Delhi. They can also choose path x and then path 2. Similar one can choose path x and then 3 and x then 4. So there are 4 ways of traveling to Delhi if the person choose path x. And similarly, if they choose the path y first, then there are 4 ways of traveling to Delhi. And if they choose path z, there are the 4 ways for reaching Delhi as well as. So step 3. So in total, there are 4 plus 4 plus 4 equal to 12 ways of traveling to Delhi, or we can alternatively say that total number of ways of traveling from Kota to Delhi via Jaipur is m cross n, that is 3 into 4 equal to 12. As the event happens in succession, one after the other, we have used the rule of n. Therefore, we multiply the possibility of both the event k to j and j to d. Alternative solution. Through the process of selection, we can find there are 3C1 ways of traveling to Jaipur from Kota. Any route can be selected from the 3 available routes. In similar ways, there are 4C1 way of traveling to Delhi from Jaipur. Any route can be selected from the 4 available routes. Therefore, the total number of ways of traveling from Kota to Delhi via Jaipur is 3C1 cross 4C1, which is also equal to 12. Now for the part B, let the P the number of ways of reaching Delhi from Kota via Jaipur and Q be the number of ways returning Kota from Delhi via Jaipur, with the condition that the same route is not taken. Therefore, the number of ways in which a person can take a round trip, provided that the same road has not been taken while coming back to Kota, is P cross Q. So we know that P is equal to 12. Step 2. Delhi to Jaipur. As the same road not taken again, the number of possible route is 3. Jaipur to Kota, similarly the number of possible route is 2. And from the return trip from Delhi to Kota, the number of possible way to return is 3 into 2 equal to 6. this implies Q is 6. So the number of ways in which a person can take a round trip, provided that same road has not been taken while coming back to Kota, is P cross Q equal to 12 into 6, which is equal to 72. Note point. The multiplication principle can be generalized for any finite number of events. Example, if a person has to travel from A to E via B, C, D, and the number of ways of traveling from A to B is n, B to C is n, C to D is P, and D to D is Q, then the total number of ways of traveling from A to E in succession is M cross N cross P cross Q, or the number of ways of event A, B, C, D, E happen in succession is M cross N cross P cross Q. Now the next rule is addition principle, the rule of OR. If there are two operations such that they can be performed independently in M and N ways respectively, then these two operations can be performed in M plus N number of ways. Suppose we have event A, different ways is N, event B, different ways is N. The total number of ways of event A or B to occur is equal to M plus N. Let's take an example. In a railway station, there are three platforms A, B, C, and a person is standing on the platform B waiting to board a train. It has been announced that a bomb is identified and everyone on the platform B has to leave. If there are 7 and 5 ways to reach a platform A and C respectively from the platform B, then find the number of ways a person can exit the platform B, therefore the bomb explodes. Both AC platforms have exit gate. So, solution. According to given situation, it is clear that person has to reach either the platform A or C from B, but not to both the platform A and C. So there is a sense of bond. So there are a number of ways in which a person can reach either the platform A or C are 7 plus 5, which is equal to 12 ways. Now take another example. Observe the road network in the given diagram. In how many ways can a person travel from A to C via B or D? Step 1. Let us divide it into two cases, via B and via D. Case 1, via B. A person has to travel from A to B and then to C, that is A to B, B to C. From A to B, there are 3 ways of traveling, and from B to C, there are 4 ways of traveling. So the total number of ways of traveling from A to C via B is 3 into 4 equal to 12. Step 2, case via D. A person has to travel from A to D, then to C, that is A to D, then C. From A to D, there are 2 ways of traveling, and from D to C, there are the 3 ways of traveling. So in total, number of ways of traveling from A to C via D is 2 cross 3, which is equal to 6. Step 3, since there was OR between via B and via D, so we have to add, and the number of ways we obtain from both the cases, the total number of ways of traveling from A to C via B or D is 12 plus 6, which is equal to 18. Let's take another example. There are 4 books, one of each physics, chemistry, mathematics, and biology. These books need to be arranged in 4 different boxes. In how many ways can a person arrange? Only one book can go in one box. Solution. Now let's start with the chemistry book. There are 4 different boxes in which the chemistry book can be placed. So there are 4C1 ways of placing the chemistry book in the box. Step 2, we are left with the 3 books and 3 boxes. Let us take the physics books now. So there are three boxes in which the physics books can be placed. So there are 3C1 ways of placing the physics book in the boxes. Step 3. Now we have two boxes and two books. Let us take the mathematics books. So there are two boxes left. So there are 2C1 ways of placing mathematics book in the boxes. Step 4. Only the biology book is left and there is only one box. So there is a one way of placing it in the box. Since we are placing the books in succession, so we will multiply the number of ways from each cases to get the total number of ways. The total number of ways arranging the book, which will be 4C1 cross 3C1 cross 2C1 cross 1C1, which comes out to be 24 ways. The next one is called digit problem. In how many three-digit even number can be performed from the digit 1, 2, 3, 4, 5, 6 if the digit can be repeated. Solution. We know that number is even if the unit digit is an even number. So now we have to form a three-digit even number. So the ones place can be filled in three ways, either 2, 4 or 6. The 10 place can be filled in 6 ways. The number can be repeated. Similarly, the 100 place can be filled in 6 ways. Observe that we will filling the digit in succession. So there is a sense of n. So therefore, in total number of three-digit even number that can be performed from the digit 1, 2, 3, 4, 5, 6 is 3 into 6 into 6, which will be 18 into 6, which comes out to be 108. Alternative solution, we can also figure out the number of three-digit even number by the selection process. 100 place, select a number to be placed in 100 place. It can be done in 6 even ways. 10 place, as a number can be repeated, the selection of number for the 10th place can be done in 6 even ways. 1 place, as the three-digit number should be even number, out of the possible number 2, 4, 6, one can be chosen to be placed in the one place. So this can be done in 3C1 ways. Therefore, the total number of three-digit even number that can be formed from the digit 1, 2, 3, 4, 5, 6 is 6C1 into 6C1 into 3C1, which also comes out with 108. The next one is called permutation. Permutation is an arrangement of R object taken out N object. Formula for the permutation, which will be NPR or PNR, represent the arrangement of R object from N distinct object. Repetition is not allowed. The NPR it comes out to be N into N minus 1 into N minus 2 dot N minus R minus 1. Proof. By definition, there are n ways to choose the first element, n minus 1 ways to choose the second element, and so on. That is n minus r plus 1 ways to choose the rth element. So the product rule that gives us PNR will be n minus 1, n minus 2, and so on, n minus r plus 1. So these are the some properties of permutation. The first one is NPN, which is equal to n minus 1, n minus 2, dot 3 to 1, which comes out to be n factorial. Second property is NP0, which is n factorial upon n factorial, which comes out to be. Third property is NP1, which is n. The fourth property is NPN minus 1, which comes out to be n factorial. The fifth property is NPR, which is n dot n minus 1 PR minus 1, which is also equal to n minus 1, n minus 2, PR minus 2. And the sixth property is n minus 1 PR plus R dot n minus 1 PR minus 1, which is equal to n. And that one seventh property is NPR upon NPR minus 1 comes out to be n minus R plus 1. So the NPR, which is arrangement of R object out of n distinct object. NP0 is 1, arranging nothing. NPN, which is n factorial, arranging all the things The number of arrangement, that is called permutation of n different objects taken r at a time when the repetition is allowed is n. So property related permutation. For r permutation of n, where n is greater than equal to r, which is greater than equal to 1, we have the following property, npr, which is equal to n minus 1 pr minus 1. So as we know that npr, which is n factorial upon n minus r factorial. So by taking n minus 1 factorial upon n minus r factorial, which is n minus 1 factorial n minus 1 minus r minus 1. So in the denominator, we add 1 and subtract 1. So this can be proved using the fact that n factorial, which is n minus 1, as follows: n minus 1 pr minus 1. So for r permutation of n, where n, which is greater than equal to r, which is greater than equal to 1, we have following properties. That is npr, which comes out to be n minus 1 pr minus 1, n minus 1 n minus 2 pr minus 2, n minus 1 n minus 2 n minus 3 pr minus 3, and so on. And the second property is npr, which is n minus 1 pr plus r times of n minus 1 pr minus 1. And the third property is npr upon n pr minus 1, which is n minus r plus 1. So as discussed the first property, it is just an extension of the property we have already stated. For second, this equality can be proved by considering the right hand side and simplify it. That is n minus 1 pr plus r times of n minus 1 pr minus 1, which comes out to be n minus 1 factorial upon n minus 1 minus r factorial plus r n minus 1 factorial n minus 1 minus r minus 1 factorial, which comes out to be n minus 1 factorial upon n minus r minus 1 factorial plus r n minus 1 factorial, which comes out to be n minus r factorial. To add the two fractions, we need to give them the same denominator. So we can do this by multiplying the numerator and denominator of the first fraction by n minus r and using the property of factorial, that n minus 1 pr plus r times of n minus 1 pr minus 1, which is n minus r, n minus 1 factorial upon n minus r minus 1 factorial plus r n minus 1 factorial upon n minus r factorial. After adding, we get n minus r n minus 1 factorial plus r times of n minus 1 factorial upon n minus r factorial. After solving, we get n minus factorial upon n minus r factorial. And after this, we get n factorial upon n minus r factorial, which comes out to be npr. And the last property, which is npr upon npr minus 1, which is npr n factorial n minus r factorial divided by n factorial upon n minus r minus 1 factorial. After solving this, we get it n minus r plus 1 factorial upon n minus r factorial, and again open the factorial, n minus r plus 1 n minus r factorial upon n minus r factorial, which is cancelled out, we get the result. The next one is called combination. A combination is a selection of some or all from the different object where the order of selection is not important. Combination formula, that's NCR, which is n factorial upon r factorial n minus r factorial. Represent selection of r things from n distinct things. Repetition is not allowed. Take an example. Consider 4 distinct objects A, B, C, D. The selection of 3 objects out of 4 at a time can be done in the following ways. A, B, C, A, B, D, A, C, D, B, C, D, when not repeated. Therefore, the number of combination of 4 distinct objects taken 3 at a time when not repeated is 4. So in each selection, we have 3 factorial permutation. Now the number of permutation, which is equal to the number of selection of 3 objects out of 4 objects, multiply with number of arrangement of 3 objects taken on at a time. So the number of permutation will be 4p3, which is 4 into 3 factor. So these are the properties of combinations. The first one is NC0, which is equal to NCN, which is comes out to 1. Second property NC1 is N. Third property, if NCR equal to NCP, then either R is equal to P or R plus P is equal to N. Fourth property, NCR, which is equal to NPR upon R factorial. Fifth property, NCR plus NCR minus 1, which comes out to be N plus 1 CR. Sixth property, NC0 plus NC1 plus NC2 plus and so on NCN, which comes out to be 2 to the power N. Seventh property, NC0 plus NC2 plus NC4 plus and so on, which is comes out to be NC1 plus NC3 plus and so on, which comes out to 2 to the power N minus. Eighth property, NCR, which is equal to N upon R, N minus 1, CR minus 1, which comes out to be N minus 1, R minus 1, NC2, C, R minus 2. Ninth property, 2n plus 1 C0 plus 2n plus 1 C1 plus 2n plus 1 C2 and so on 2n plus 1 Cn, which comes out to 2 to the power n. The last property, NCn plus n plus 1 Cn plus n plus 2 Cn plus and so on 2n minus 1 Cn, which comes out to be 2n C n plus 1. Now equality of combination and permutation. If NCR is equal to NPR, find the values of R. Answer, recall from the definition of combination, we have NCR, which is NPR upon R factorial, NPR, which is equal to NCR, which comes out to be NPR upon R factorial. Substituting these into the given equation, result, cross multiply by R factorial and dividing by NPR, we can rewrite as R factorial equal to 1. We might be tempted to immediately jump to the conclusion that R is equal to 1. However, this would be only be a partial answer, since recalling the definition of the factorial, we also have that 0 factorial is 1. Notice that when R is 0, we have NC0 is NP0 is 1, and R is 1. So we have NC1, which is NP1, which is equal to N. Hence, the two possible values of R and 1 and 0. Identity summation of combination. For any positive integer n, we have summation r equal to 0 to n, NCR equal to 2 to the power n. This rule may not be surprising when we consider the recursive relation for each term, that is n minus 1 CR minus 1 plus n minus 1 CR, which comes out to be NCR. Since this does not apply for r is equal to 0 or r is equal to n, so we can rewrite the sum as summation r is equal to 0 to n NCR, which NC0 plus n minus 1 C0 plus n minus 1 C1 plus n minus 1 C1 plus n minus C2 and so on n minus 1 C n minus 1 plus n minus 1 Cn, last NCn. Since NC0 is 1, NC minus 1 0 is also 1, and NCn and n minus 1 Cn minus 1 is also 1. So we can rewrite this expression as summation R0 to n NCR, which is n minus 1 C0 plus n minus 1 C0 plus n minus 1 C1 plus n minus 1 C1, n minus 1 C2 plus n minus 1 C2 plus n minus 1 C3 plus and so on n minus 1 Cn minus 1 plus n minus 1 Cn plus n minus 1 Cn minus 1. So the summation R from 0 to n NCR, which comes out to be n minus 1 C0 plus n minus 1 C0 plus n minus 1 C1 plus n minus 1 C1, n minus 1 C2 plus n minus 1 C2 and so on n minus 1 Cn minus 2 plus n minus 1 Cn minus 2 plus n minus 1 Cn minus 1 plus n minus 1 Cn minus 1, which comes out to be twice of summation from R0 to n minus 1 n minus 1 CR. So therefore, the sum of NCR is twice the sum of n minus 1 CR. Moreover, the since 0 C0 is 1, so we can also see the sum of NCR for a given n will be the power of 2. In particular, it will be 2 to the power n. Formula: recursive relation in combination n minus 1 CR plus n minus 1 CR minus 1 equal to NCR, where R is from 0 to n. To derive this formula, we can use the definition of NCR to write the left hand side as n minus 1 CR plus n minus 1 CR minus 1, which comes out to be n minus 1 factorial upon R factorial n minus R minus 1 factorial plus n minus 1 factorial upon R minus 1 factorial n minus R factorial. We would like to express this as a single fraction over the common denominator of factorial R into factorial n minus R. We can do this by multiplying the first term by n minus R upon n minus R and the second term by R upon R as follows: n minus 1 CR plus n minus 1 CR minus 1, which is n minus R, n minus 1 factorial upon R factorial n minus R, n minus R minus 1 factorial plus R n minus 1 factorial R minus 1 factorial n minus R factorial. Using this properties of fraction that factorial n is equal to n of n minus 1 factorial, we can rewrite this as n minus 1 CR plus n minus 1 CR minus 1, which is equal to n minus R n minus 1 factorial upon factorial R upon n minus R factorial plus R n minus 1 factorial upon factorial R n minus R factorial. Expressing this as a single fraction and expanding the parentheses, we have n minus 1 CR plus n minus 1 CR minus 1, which is n minus 1 factorial minus R n minus 1 factorial plus R n minus 1 factorial upon factorial R upon n minus R factorial. After resolving this, we get it n factorial R factorial n minus R factorial, which will get NCR as a result. Now let's take an example from the word Ganeshpuri. How many 3 letters words can be formed? Second, how many 4 letters words can be formed? Third, how many words can be formed using all the letters? Fourth, how many words can be formed using all the letters that start with the letter Z? Part 2, how many words can be formed using all the letters in the following condition that begin with the consonants, begin with the consonants and end with the consonants, begin with the consonants and end with the vowels. Solution: how many 3 letters words can be performed? Given words Ganeshpuri, total letters is 10, number of ways is 10p3. How many 4 letters words can be formed? Given word Ganeshpuri, total letters 10, number of ways is 10p4. How many words can be formed using all the letters? Given word Ganeshpuri, total letters 10, number of ways is 10 factorial. 4. How many words can be performed using all the letters that start with the letter Z? Given word Ganeshpuri, the total letter is 10 and the number of ways is 1 into 9 factorial equal to 9 factorial. Begin with the consonants. The given word is Ganeshpuri. So here the first place can be filled by 6C1 ways and the remaining place can be filled in 9 factorial ways. Thus the total number of ways is 6C1 into 9 factorial. Part B, the begin with the consonants and end with the consonant. The given word Ganeshpuri, the total letters is 10, total consonants is 6. So here the first and the last place can be filled by 6C1 and 5C1 ways. Thus the total number of ways is 6C1 into 8 factorial multiplied by 5C1. And begin with consonants and end with vowels. The given word Ganeshpuri, the total letters is 10, total consonants is 6, total vowels is 4. Here the first place can be filled by 6C1 ways, and the last place can be filled by 4C1 ways. So total number of ways is 6C1 into 8 factorial into 4C1. Last is division and distribution. That is, things can be distributed, place and person among which the distribution is to be done, and method. So different example, if 5 different books are to be distributed into 3 different boxes, that's different, divided into the group method, then distribute. Number 2, if 5 different books are to be distributed in 3 similar boxes, that is like, divide into the group method, then distribute in one way. 10 similar coins to be 3 different beggars, different beggar method, and the 12 similar coin to be 3 similar boxes alike, group formation. Let us consider four people, and let us divide them into unequal group of size 1 and 3. Number of ways is 4 factorial upon 1 factorial upon 3 factorial, which comes up to 4. The division of the 4 people into 2 unequal groups of size 1 and 3 be done by the following manner. Therefore, the total number of ways is 4C1 into 3C3 equal to 4 into 1, which comes out to be 4. Explanation. In this given case, the first we have select a single person out of 4 to make a group of size 1. For the second group, we have a total of 3 people, and out of those 3, we have to select 3 to make the second group of size 3. Thank you.